Okay guys, Professor Doney back here for part 2 of your introduction to trig. And again, we need to get into trig to be able to do some problems in two-dimensional motion where we project something, launch something, drive it off a ramp. So where we left off was having a right triangle, meaning it has a 90 degree. We had a short side, which is called adjacent. We had an opposite side, again opposite from this angle, and we called that the hypotenuse. And again, Pythagorean's theorem said if I take the adjacent squared plus the opposite squared, it'll equal the hypotenuse squared. And that's Pythagorean's theorem. But we're using the trig, and where we left off with is the cosine of theta, which is the angle, is the adjacent side over the hypotenuse. We had the sine of theta equals the side opposite, sine side opposite over hypotenuse, and then we had tangent, which we don't use as often, but that helps us get the angle sometimes. That was the opposite side over the adjacent side. Now the way we're going to use these is to just rearrange these equations a little bit. And the way we rearrange them is we want to get the angle by itself. Okay? And the way we can do that is we take what's called the inverse of this trig function. So it would be inverse cosine. Some people call it arc cosine. I think that's correct. But the idea, on your calculator, there's probably an INV or second button, and you push that so you can access where it says cosine, but then also it should have like a cosine with a -1 up there. That's what we're trying to access. So a lot of times you have to hit inverse cosine or second cosine on calculators to get to that. And what we're trying to do is if we can find the angle by taking the inverse cosine of that adjacent over hypotenuse, we can do the same thing with inverse sine. That gives us the opposite side over hypotenuse, and then we can also do tangent, inverse tangent. Again, it could be arc sine. I may not be correct on that, but you get the idea. So if I know what the adjacent side is, how long it is, and I know how long the hypotenuse, I took that value over that, find the division or the ratio of it, hit inverse or second cosine, it'll tell me the angle. And basically that kicks out the angle in degrees for us. And we can do that for all of them. Now, for what we need to do it for our trig, we want to use it in a little different form. So I'm going to get rid of this real quick, bring up the new window, and here's how we're going to take those same things and rearrange them to be the adjacent side is equal to the hypotenuse times cosine of the angle. The opposite side equals hypotenuse times sine of the angle. And we could use tangent, but we're just going to stick with those for now. So taking those three original equations we had, which were cosine of theta is adjacent over hypotenuse, I'm going to rearrange it and multiply both sides by hypotenuse. I get this. What that means is if I know this number, let's call it 10, and I know this angle is 30, I want to find out what this adjacent side is. I want to find out what this opposite side is. And so what I would do for the adjacent, I would say 10, which is the hypotenuse, times cosine of the angle, times cosine of 30 degrees, should give me 10 times 0.866. It should give me 8.66. If I do the same thing for opposite, I take the hypotenuse, which is 10, times sine of the angle, and that should be the same as 10 times 0.5, because sine of 30 is 0.5, and that should give me 5 for the opposite side, 866 for the horizontal side. Now before we get to the next video, because that 5 minutes went quickly, you need to check that your calculator is set in degrees. If it's in degrees and you take the sine of 30, you'll get 0.5. You take this cosine of 30, you get 866. If you're in radians or rads, which we don't want, you'll get something different. So make sure your calculator for the next part is set in degrees, and then we're going to come back here and finish up this quick on trig. It's taking a little longer than I expected, but I want to make sure I hit this real hard for you. So we'll see you in a few seconds.